Scientists and engineers in Japan are researching how microalgae can be used to produce biofuel that can power a jet. That will take a lot of algae. Algae naturally grows in aquatic ecosystems. To scale and control the production of algae, scientists and engineers have built the first biorefinery in Yokohama to create mass cultures. Open ponds are commonly used in the mass cultivation of microalgae. They are cost-effective and energy-efficient. The exposure to air, however, makes these ponds vulnerable to parasites which harm the algae and stifle its growth. Closed-loop systems are not exposed to open air, so they are safe from pesky parasites. However, these systems require a source of sterile carbon dioxide. Photobioreactors, tubes of nutrient-rich water exposed to a controlled light source, are an example of a closed-loop system. They allow for greater control of the culture than open ponds, but they are a costly option and difficult to scale. A huge benefit of cultivating algae by any of these methods is that they don't use up arable land like crops used for biofuel do. And algae can produce more oil and lipids per unit of biomass per weight and per unit of land compared to crops like corn and soybeans. Various microalgae show promise for biojet fuel production. In a process called hydrothermal liquefaction, wet algae are subjected to high pressure and heat to break down and remake the chemical building blocks into biocrude oil. Once the oil is extracted, it's processed into fuel. Today, the cost of cultivating algae, extracting the lipid, and purifying the fuel make this a pricey fuel alternative. But as scientists and engineers improve these processes, microalgae biofuel is likely to take off.